Part 4 is the fourth in a series of animations to describe the buildability of the Buoyancy Engine, including a route map to delivery of a large-scale working system. In Part 3, a scaled animation showed the operating principles of the hydropower option. Here, an alternative working model is shown. Rather than generating electricity by allowing a flow of water to drive a turbine, the electricity is produced by a generator integrated within each of the outer drums. Once the storage vessel has descended, electricity may be produced on demand. As the storage vessel ascends, it spins the generators. This is a simpler design. Turning forces are applied to the outer drums, which then spins the generator. The pontoon and storage vessels are large structures. However, modular design principles would be used to keep manufacturing costs down. High-density plastics would be moulded into segments. These are then welded together to form a series of torus. These are assembled on a jig and connected by joining pads to form large, very strong vessels. These would be much cheaper than ship or submarine structures, which involve considerably more onerous design and construction procedures. As part of the design, it may be necessary to interlink torus sections. This would depend on the outcome of detailed design analysis. Once structural and operational aspects had been fully assessed, the design would be frozen. The inverted cup bases would be lowered to the ocean floor using a winch with active compensation for wave motion. Once positioned, they would sink into the silt bed under their own weight. A partial vacuum would then be applied to a compartmented volume within the base until the desired depth and incline is achieved. A drill set would then be lowered and fixed to the base using hydraulic clamps. The drill would then be powered via an umbilical, either back to the surface support crew or to a subsea power grid. Once the piles are drilled, a reinforced cage would be lowered before the pile fill is pumped and allowed to cure. Drum and pulley sets would then be fixed before positioning the storage vessel and pontoons. The cable can then be threaded from the outer drum through to the storage vessel. Before a full-scale model can be deployed, there would be a number of preliminary stages, including a laboratory validation and design model. This would be followed by small-scale sea-trial prototypes. Criteria for the phases are set out in the tank testing of Wave Energy Conservation System paper, as produced by EMEC. Any potential investors or suppliers should contact us using the details given in the animation credits.